Hey guys, so Boyle's law is what we're going to talk about today. And if you remember from the kinetic molecular theory, under constant temperature, when a gas has a change in pressure, the volume is going to change inversely proportional to that. So what that really means is that if you take a look at this formula here, I've got an initial pressure and an initial volume. And that's going to change, gases can change into a new pressure and a new volume. And all that this law really states is that if, let's say, the pressure of a gas increases by a factor of 10, and if the gas's pressure changes by a factor of 10, that's going to have an effect on the volume. And it's going to have an effect on the volume in an inverse relationship. So the volume is going to go down, and because it's proportional, it's going to go down by the same factor, so by a factor of 10. And so this formula is set up such that it shows this relationship. So if I take if I multiply the initial pressure by the initial volume, I should get the same answer when I multiply the final pressure and the final volume together, because if this number goes up by 10 and this number goes down by 10, or by a factor of 10, then the multiplication of those two numbers will still be the same. So for example, if this was 100 kPa, the initial pressure, and the initial volume was 10 liters, and let's say that the pressure of that gas went to 1,000 kilopascals, then I know that the volume of that gas is going to go down by a factor of 10, so it will be 1 liter. And this makes sense. If you take a look at this, 100 times 10 equals 1,000, and 1,000 times 1 equals 1,000. And so this is how this formula works. So I've got a practice question here and how I want you guys to do these questions and show you how I want you to show the work and whatnot. So let's jump into that one. It says that I've got a 1.00 liters of a gas, so that's the initial volume of that gas. So I'm just going to write that in right here as I'm reading the problem, jot down the numbers that I'm given in the question. And that gas is at STP, so it's a standard temperature and pressure condition. And so the pressure of that gas is going to be 101.325 kPa. And it says that this gas is being compressed. So if it's being compressed, obviously that means that the gas is going to be under a higher amount of pressure, which means my volume is going to be smaller. And you can see that it gives us the volume. It says the volume is 473 milliliters. So that volume is smaller than 1 liter, and so that goes here. This is my final volume. Now, something that you have to make sure that you're doing when you're doing these types of problems with Boyle's law and the other laws that we're going to talk about is that your units need to be consistent. So if I have liters here for V1, then V2 also needs to be in liters. Now here in the question, it doesn't give it to me in liters, it gives it to me in milliliters, so I'm just gonna convert that into liters. So now my units are consistent, and the reason why for this is so that the units can cancel. My final pressure is what the question is asking for. It says, what is the new pressure of the gas? So that's what I need to figure out. So I come over here to my formula and I just want to solve for P2. So algebraically, this is just a simple move of getting P2 by itself by dividing this by V2. So the V2s cancel and V2 goes over there. So that means that P2 is equal to P1 V1 divided by V2. And if I want to calculate P2, then I just plug in now my numbers that are here into my formula, making sure that you put your units in the formula and that you are showing your work as you're going along doing this. So you plug this in and you get 101.325 kilopascals times by 1 liter divided by 0.473 liters. And so you plug this into your calculator and you get an answer. Now what does your answer come out as? Well, your answer comes out as, you can see the liters cancel out, and your answer is going to come out as kilopascals. Now it turns out that this is question number 1 in your practice booklet in the Boyle's Law section. And if you look at the answer that I've provided to you, the answer is in atmospheres. And so the answer that you're going to get in your calculator here, while the number you get is the correct number, it's going to be in units of kilopascals. So it's hard for you to compare kilopascals into atmospheres. So you can solve this one of 2 ways. You can take your answer in kilopascals and convert it into atmospheres, as per the video when we talked about converting pressures. Or another thing that you could do here is, okay, hey, the answer that I've got in the booklet is in atmospheres. So if I want to compare my answer and make sure I've got it right, I'm just going to put atmospheres into the question. And if you remember, 101.325 kilopascals is just 1 atmosphere. And so you could do that like this. You could take this number here instead and put it in as 1 atmosphere. And now when you plug this into your calculator, you're going to get 2.11 atmospheres. And that's your correct answer. So when you're doing a question, or if you're doing a question on an assessment or whatever, and you're wondering, okay, well, what unit should I write my pressure units in? Remember that for these types of formulas, all you need to have is that your units need to be consistent. So if I have liters here, I need to have liters here. If I have atmospheres here, then my answer is going to punch out as atmospheres. If I have kilopascals here, my answer is going to punch out as kilopascals. You could have milliliters and milliliters. It's okay as long as the units are consistent. And then on a test, for example, or an assessment that I might give, if I want a particular set of units, then I will state that clearly in the question, where I will say, express your answer in atmospheres, or express your answer in kilopascals. And so there's no guessing there for you on that.